back into this, and now we see how electricity and magnetism are really related. Because the magnetic field is created by a moving electric charge. So imagine there's an electron stream flowing this way, or maybe even just a slew of electrons, or maybe even one electron going by. As an electron goes by, it creates a magnetic field that kind of whips around it. Okay, that looks like it going in that motion, kind of like a spiral around the area where it moves. And the closer you are to where the electron's moving, the stronger the magnetic field. And as you go away, it kind of becomes weaker. And so that causes a magnetic field that looks like this loopy thing that's going around. There's a rule to this, and we're going to learn about three different right-hand rules. And whenever we talk about negative charges, I want you guys to use your left hand. Whenever we talk about positive charges, use your right hand. Okay, so keep that straight. Left hand negative charges, right hand positive charges. And so here's an electron, and if you were to make a fist and point your thumb towards the electron flow, the way your fingers would be curling would be the direction of the magnetic field. So when I say the magnetic field looks this way, this is the up part here is north and the down part is south. It's always going from north to south, from north to south. So there's really no north or south. It's kind of like moving in this loopy thing where depending on where you're looking at it, it's a north or a south. The next picture kind of illustrates this a little bit better when I say how you're going to grab it. So say you have a positive current now, it's a regular conventional current going through this wire in that direction. So now you're going to grab it with your right hand as this picture is done here. And the direction these fingers are pointing is the direction of the magnetic field. See that? It's pointing this way. I'll show you in a bit how you can figure out north to south, but here is the direction of the field. So you know which way the lines are going, okay? The direction of the arrows. So again, you grab whichever way the current is going with your thumb pointing in the direction of the current. And the way your fingers point will be the direction of the magnetic field. Remember, right hand. Now, if that current itself was going through this piece of paper, and I put some iron filings around it, you can see how it made the spiraling thing because that's the shape of the magnetic field going around this wire that's going through the paper. Now for a moment think, what if I, instead of letting the charge go in a straight line, I made the charge itself loop around, like over here. So you see over here, the electric current is going around this loop. So what happens here? Well, if you take your thumb and you point it in the direction of the current throughout this entire region as you go around it, you'll find that your fingers always point into the ring as you take your hand around it, going from this end over to the other. Okay, so imagine the current is going in that direction. You take your right hand and you keep your thumb in that direction, and you see how your fingers curl in this way. Well, that would be the picture as you go around. So it almost looks like the field lines go into here, and this is kind of got this field lines that are going in from here and coming out of here. So it's coming out of the North Pole and going back into the South Pole. And so if you took a lot of these loops together and you put them in one by one, you could see that each one of these creates a magnetic field. So in this case, we have the current going in that direction. And so if you take your thumb and point it in this direction as you wrap your hand around this coil, you'll see that your fingers come in from underneath here as if it's coming out of there. And so as you go around this, you feel like all these little field lines add up. And so making the current go in a loop like this makes the magnetic field come out of the loop like this. Well, this becomes like a North Pole because that's where the field lines are coming out of, and that's the South Pole. You can even model this with your right hand by using a second right hand rule. And this was the first